All right, in this screencast, we're going to learn how to name transition metals. Now, transition metals make it a little more challenging to name because transition metals can take on more than one possible charge. So you need to indicate in the formula, indicate in the name what the charge is in the formula. So if you look at the Fe2O3 and the FeO, you have an example of iron in two different charges. In this case, we have iron is a +3. And over here, iron is a +2. So when we get around to naming these iron-oxygen compounds, we have to indicate that one of them's a +3 and one of them's a +2. On the left, we have iron 3 oxide. And on the right, we have iron 2 oxide. So when you would be reading the names of these compounds, you would now know how to correctly write the formula based on the charges of the iron. All right, so how do you know when you need to use a Roman numeral? Well, we are going to use Roman numerals to show the charges when you have a transition metal or a metal with more than one charge. We know that this column is +1, this column's +2, over here's +3, we get -3, -2, -1, 0, and we have plus or minus 4. When you look at these center sections and these elements over here, they all have multiple charges. And you will have to use a Roman numeral to show what charge you're dealing with. So these are known as the transition metals. So anytime that you have an element in these sections, you will need to use Roman numerals. Now you will not need to worry about zinc and silver because we know their charges. Zinc is +2 and silver is +1, and you won't have to use a Roman numeral with them. But for the other elements in the transition section, as well as tin, lead, you will need to use a Roman numeral. All right, so the process in naming a compound that has a transition metal is a little more complex, and it has a couple of steps. So in the first step that you want to do is you want to look up the charge on the other element. And in this case, we have oxygen, which is -2. So we're going to find the charge on other element. Okay. So once you have the charge on the other element, you need to figure out how many total negative contributions you're making to this whole compound. So the second step is going to be multiply the charge and the subscript. So we are going to multiply down, and we will get the total negative contribution is -10. Okay. The third step is going to recognize that you have to have a net charge of 0. So whenever you have 10 negatives on the right, you now need to have the same number of positives on the left for this compound to exist. It had an overall charge of 0, so the number of negatives have to balance out with the positives. The fourth step that we're going to do is we're going to figure out what each individual element contributes to the overall charge. So we're going to divide up. Okay, so what you will do is you'll take your 10, your positive 10 here, and the 2 from the V2, and you're going to take 10 divided by 2, and that will give you an overall charge of +5. And that number that you get, the resulting number, will then be the charge on this particular element. So in the formula, in the name, we would call vanadium, and our charge gets to be a Roman numeral, and then we're going to name the second element, again, with just either a polyatomic or an IDE ending, depending on what the name of the second part is. So this is vanadium 5 oxide. My students often have problems with this, so I'm going to show you the example from the beginning of this screencast, doing the math, and then we'll do a couple more examples. So remember, the first step is to look up the charge on the other element, and oxygen is -2. The second step was to multiply down, so we're going to have -6. We have to make the same number of negatives as positives, so we will have +6. And then we're going to divide up. So 6 divided by 2 gets me a 3. So we'll write that back up here. Then the name of this one is iron 3 oxide. Okay, let's show you this other one over here. We looked up the charge of the other element, oxygen. We are going to multiply down. 2 times the understood 1 would get us -2. We make the same number of positives as we have negatives. We divide up. 2 divided by the understood 1 means that my charge is +2. So this one is iron 2 oxide. Now, a rule of thumb. You should not see Roman numerals above, we'll go with 5 or 6. If you see anything above 5 or 6, that should be a very clear indicator that somewhere you did the math wrong and you need to go back and start again. All right, let's work this problem together. CrSO4, we see that Cr is a metal in the middle and we need to have a Roman numeral. So we're going to look up the charge on the SO4 and it is -2. The next step was to multiply down, and if you multiply down, -2 times 4 gets you -8. When you make the same number of positives, you would have a +8, and then you divide up, and you should be asking yourself, whoa, wait, that is going to get me a Roman numeral that is way bigger than we should have. And I did this problem on purpose just to illustrate what it will look like if you've done it wrong. So let's back up, make all these numbers go away, go back to the step where we multiply down. When you multiply down, you are multiplying by the entire polyatomic and how many of them you have. In this case, we have 1 SO4, sulfate. So we need to multiply our -2 times the fact that we have 1 SO4 to get -2. Now, when we go ahead and make our positive number, we have +2, and then we will divide up, and we will end up with an answer that is chromium 2 sulfate. So, the problem lies in whenever you're using a polyatomic. If there's only one polyatomic present, you have to be careful that you're not multiplying by part of the polyatomic. Here's 2 more examples, both with polyatomics. And one is, they're both pretty simple actually, but we'll work them through. Chromate is a -2, and when you multiply down, you get -4, make it +4, divide up. So this one becomes lead 4 chromate. All right, SnCN in parentheses 2. We're going to multiply by the charge. That gets me a -2, +2, divide up. So 10, 2 cyanide. You will need to practice these. We will have worksheets in class. Make sure you set them up and solve them, but the key thing is to identify what the charge is and multiply.